This is part 2 of the Genesys Getting Started and shows more advanced features of the Genesys core. In this video, we're going to continue with the design we started in the Genesys Getting Started part 1 and show some more advanced features of the Genesys core. One thing that's very important to know is under the Tools menu, there's an Options menu. And there's a number of tabs, as you can see, and this is for setting up your global options. And you can set them up for your schematic capture and your graphing. And one very important one is your units. You want to go in and set up your units for your global options. So one feature that a lot of people would like to do is we showed a tuning of a single component in the part 1. But what a lot of people would like to do is be able to gang tune or tune more than one component at a time. So for example, these two inductors you might want to tune together. And the way to do that is you go to your workspace tree, and as you notice there's an equation block in the workspace tree. If you double click on that, it opens up the equation block. And here you can type in equations. You can also do all kinds of post-processing and control loops, and it has a lot of capabilities, but we're going to just do a very simple equation here. I'm going to say L is equal to question mark 25, and what that means is that the variable L is 25, but it's the question mark makes this tunable. So if I click go, you can see over here it says L is equal to 25. And one thing you want to be sure and set when you're doing equations is, if you notice it says here units, if you click on that, you can either use MKS or display, and we want to use display. That's going to use the units that are displayed in our schematic. So if I close the equation window, and what you can do is open up the inductor, I'm going to uncheck the tune button, and I'm going to make this L, the variable L, so the inductance is now L, and I'm going to do the same thing in the second inductor. So I'm going to change it to variable L. So now both inductors have their inductance as L, if you can see in here. And so what I want to do now is, if you go to the toolbar, the schematic toolbar, there's an icon that says it's an annotation toolbar. If you click on that, you can see there is a slider here. If I click on the slider and place it on my schematic, you can create a slider for tuning the parts. And so if I double click on the slider, use this ellipsis button to select the L in the equation, and I'm going to leave it from 0 to 100 with a number of ticks 5, and I'm going to hide the name prefix so that all it shows is L. And let's go back and open it up, and now you can see that we have a slider. Let me expand the slider a little bit so that you can see it. And if I also notice that when you made the changes to the schematic, this is important, we have everything turned red, the simulations turned red, and they say old data in the workspace tree. You notice there's also an icon that looks like a calculator that turns red up here. This is your calculate button. When it turns red, it means that there are some analysis within your workspace tree that need to be recalculated, and all you do is click on the calculate button and it recalculates, and it turns green. So now if we want to tune, all you have to do is grab this tuner, and as you can see, as I'm tuning, the values in the inductors are changing, and the response in the graph is updating as I tune it. So that's one way that you can gang tune, and also shows how you can add a slider to a schematic. You can also add this slider to a graph if you so desire. Now, the next step is we might want to create a layout of our design. So I'm going to remove our tuner here now. And one thing is that if you want to create a layout, then you need to add in some microstrip lines to connect them, because right now they're just connected in a node, and that's not going to connect the parts together. At least in a discrete design, you need to add some connecting lines. But first, we need to add a substrate before we create our layout. And if you go back to the workspace tree and again use the new item button, remember this is very important. The new item button, you come to that for adding almost anything to your workspace tree, and down at the bottom you see you have add substrate. You can enter in the parameters for your substrate here, or if you notice there's a copy from button at the bottom left. If I click on that, it opens up our substrate library where we have standard FR4. We also have GE, Rogers, and Taconic standard substrates. So I'm just going to use a standard FR4, and I'm going to copy and paste the substrate into the name and then say OK. And if you notice, it added the substrate to our workspace tree. So now what I'm going to do is I'm going to move I have to hold down the Alt key if I want to disconnect it. That's one thing that's nice to remember. If you hold down the Alt key when you move something, it will disconnect the parts. And if all you have to do is draw a box around the parts you want to move and move them out of the way. Then I'm going to come back to remember the icon that looks like an op amp. If you click on that, it opens up the part groups toolbar, and I'm going to pick the microstrip toolbar and pick a microstrip line and place it on my schematic. If I double click it, it opens up and it shows the width. I'm going to make it 70, and then the length I'm going to make 200. So you notice it already has the FR4 listed as the substrate. So that's a 70 mil width line, 200 mils long, and I'm going to need 3 of those. So I'm just going to do the Control D twice and duplicate them, and then I can just drag them over and connect them up. And what we'd like to do is this one needs to be rotated, so remember you can use the rotate or F3, and we'll connect it to our capacitor, and then just hover over and connect up our lines. So now they're all connected via a microstrip lines. So if we want to create a layout, all you have to do is right click. Let me expand our schematic again so that you can see it. There's a tab at the bottom of our schematic, and if you right click on that tab, say add layout, it creates a layout of the schematic. They're connected by what we call rubber band lines to show how they're connected, but to automatically connect them, you just do a Control A to select them, or you can just draw a box around them, either way. And then you notice when you were in layout, we now, instead of have a schematic in the toolbar, and now it says layout in the toolbar. If you do the pull down for layout, you notice it says connect selected parts. You just select that and it automatically connects the parts together. So we've created our layout of our schematic, and what I wanted to do was to show that since we added these connecting lines, that's also going to add some capacitance, inductance, and so forth to the circuit. So here is our response without the connecting lines, and if we then simulate, you notice our response changed quite a bit by adding our connecting lines. Now if we wanted to verify, let me close some of these toolbars that we have here. And if we wanted to verify our schematic by performing a momentum simulation on our layout, we could do this, and that's not part of the core, but if you go under the new item button and under analyses, we can select a momentum GX analysis, and we could perform a momentum analysis of this layout. Thank you for your time. Please feel free to browse other Genesys videos on this website. For more information about Genesys products, please contact your local Agilent eSoft representative or select the More Information Related to this video link on the same page.